Okay, let's talk about determining these linear equations. So, in order to determine these linear equations, you really only need two bits of information. Okay, you're going to need to know either the gradient and 1 point on the line, that'll be enough, or you need to know the two coordinates that are on the line itself. Okay. With either of those, the gradient and 1 point or the two coordinates on the line, you'll be able to work out or determine what the linear equation actually is. So let's have a look. We'll start off with this first one here. Let's just say that we know the gradient and 1 point on the line. Let's say that we know that the gradient is negative 2, sorry. Here's the gradient, negative 2. And we also know that the y-intercept is 3. Now, that y-intercept of 3 would actually look a little bit like this. It would be 0, 3. The 0, of course, is the x-coordinate, because the y-intercept is always when x is 0, the y is that 3. So we would write down the formula, or the general form of our linear equation, y equals mx plus c. So in this instance, we can just substitute in the things that we know. We know that the m here is just going to be negative 2. And we know that the plus c, well, that plus c, the c is just the y-intercept. So it's just the 3. So when we put that all together, you will see that we have got y is equal to negative 2x plus 3. And that really is our linear equation. That is the equation for that line, based on the 2 points, the gradient and 1 point, which was this first one, the gradient and 1 point. Okay, let's have another quick look. Often you won't be told that it's just the y-intercept. You won't know that it's the y-intercept, or be given it. So here we've been given that we've got again, a gradient of negative 2, and we're told that it's passing through the point of 1, negative 3. Now don't forget, this is the x value. Oh, that didn't work very well. This is the x value, this is the y value. Okay, so, well, what can we do with this? Well, we know that in each of these, you always need to state the general form. So there it is there, y equals mx plus c. That's the form we're trying to get it into. So we already know m. So we could say that y is equal to negative 2x plus c. It's this plus c we need to now sort out. Now we know that the c is always the y-intercept, and we were not given the y-intercept. We don't know what y is when x is 0. So we have to work that out. So we would write, when x is equal to 1, y is equal to negative 3. We substitute in those values into our newly mostly figured out form, right? So we go x will be 1, here it is here, and the c we don't know, but the y we do, and it's negative 3 right there. We can then solve this equation because we've only got one unknown. The one unknown that we don't have is the c, so we are solving for the c. So we can do that. We could say that negative 3 is equal to minus 2 plus c. Well, I need to get c by itself, so I'm going to add 2 to both sides. Negative 3 plus 2 will give me negative 1. So I now have my value of c. My c is negative 1. So I can go back and I can rewrite this partial equation and actually put in what our value of c now is, and we will end up with y is equal to negative 2x minus 1. And that is the specific linear equation for the line that I was asked to find. Okay, very good. What about the other variety? When we are only given 2 points. All right, so here's our 2 points. We are given negative 2, 6, and we are given 3, negative 2. So, again, we always write down the general form, y is equal to mx plus c. First thing we're going to need to do here is to actually figure out what our m value is. Okay, so we're going to write down our formula for finding out our gradient. Here it is here. Y is equal to, m is equal to y2 take y1 over x2 take x1. Now, I've shown you before in class, it doesn't matter which is your y2, so long as your x2 is in the same. You could have this as your x2, y2. This could be your x1, y1. But you could have this as your x2, y2, and this as your x1, y1, and it does not matter, so long as the pair has the same little subscript, as long as they're both 2s or both 1s in the same pair of brackets. Okay, so we can then substitute in. I actually stuck with the red one and not the blue one, so I'll get rid of the blue ones. I don't want to confuse you. So we've got and determined our y2s and our y1s and our x2s and our x1s. We're going to substitute in. It will be -2 minus 6 over 3 minus -2. The top will become -2 minus 6 is -8. The bottom is 3 minus -2, which is really 3 plus 2, which will be 5. And we have our gradient. So to save space, I haven't gone down. I've kind of written this over to the side a little bit. You'll see. So we write in our partial equation. We've got y is equal to our value of m, which is -8 over 5x plus c. Very good. We don't have a y-intercept. We don't know what it is when x is equal to 0. So we just have to deal with what we have already got. So I'm going to use my value of x1 and y1 to figure out what my c is. So I'm going to say when x is equal to -2 and y is equal to 6, I'm going to substitute in my values of, here's my x value in the place of x, and here's my y value in the place of y, so that I can work out all of this. My c, that's really what I'm trying to do. I'm just going to simplify this. I can multiply out that bracket. I'm going to end up and then have to take that away. I'll be taking away 16 over 5 on both sides. So I get c by itself, and I work out that c is equal to 2 4/5. So I can then put that into my answer here. I can say that y is equal to -8 over 5x plus 2 over 4/5. There's a little bit of a problem with the way that I've sort of written this. The problem kind of is that this is a mixed fraction, and this is this is a improper fraction, and that's a mixed fraction. We really should try to keep it the same. So I guess this would have been more accurate to say that this was -1 3/5 x plus 2 4/5. Okay, that probably would have been a little bit better. Anywho, we could also have written it in decimals. We could say that it's -1.6x plus 2.8. Either way, that is correct. Okay, so that is how you can find your linear equation based on 2 bits of information. If we go right back up to the top up here, you'll recall that we need one of 2 things. We either need the gradient and 1 point on the line, or we need 2 coordinates that are on the line. If you have them, you can work out everything else. Okay?